Efforts to bring complete mechanization to mail processing continue through in-depth research into latest scientific techniques and development of operational hardware. Reduction of human effort, removal of the lifting and movement of heavy burdens from human muscle to the sinews of machines, improvement in methods for processing an ever-increasing volume of mail. These are some of the fields in which R&D engineers are delving and finding new answers. This film will show you a few of the many areas of research underway and some of the developing hardware. The use of controlled compressed air, called fluidics, is getting increased attention for possible use in processing mail. Utilization of fluidic control devices could eliminate many moving parts and reduce maintenance costs. As seen in slow motion, this test device in the Postal laboratory rolls letters over by controlled jets of air. This fluidic device separates machinable letters from those which will not pass through mail processing machines. Another air-jet control device gates letter mail in transit from one path into alternate paths, while this one diverts mail automatically. Notice the first decision location, where the stream of letters is diverted to left or right. And then, farther down the stream, where other control jets again divert letters in two directions. In the Postal test laboratory, this edging device uses directed air jets to edge mail on its long side as it comes over a conveyor belt. An air control device in a Postal contractor's laboratory presents an unusual idea for culling mail. This prototype has been developed to separate letter mail from other collection mail. Small parcels, papers, large flat envelopes, rolls, and the like. Assorted collection mail is emptied into the hopper of the device. An inclined moving belt carries the mail to an open mesh screen-type conveyor at the bottom of the culling chamber. Air forced through the screen at 1,350 feet per minute floats mail light in relation to its surface area to the top of the chamber. Here, a second mesh-type moving belt carries them against it to a separating conveyor. Mail that is heavy in relation to its surface area remains on the lower belt and is carried to a different separation. 40,000 pieces of mail per hour can be handled in this mixed mail air color. Here in another contractor's laboratory, R&D Postal engineers are working with industry engineers to develop a fluidic pacing and canceling machine, which will operate at very high speeds. This breadboard model does not have sensing or canceling equipment, but performs by fluidics the mechanical functions performed in the facer cancelers in use in post offices today. One of these functions is letter feed. Letters are pulled over a high-speed rotating drum by vacuum one by one from the bottom of a stack. Acceleration wheels speed up the letters and they are propelled through the system riding on a cushion of air. Because of high-speed transport, slow motion has been used to film some of the process. Note that the letters pass into the breadboard model on their flat sides. Letters face up and with stamps leading move directly through the machine into a stacker tray. Letters face down but with stamps leading are rolled over and then sped directly to the stacker. Letters face down, but with stamps trailing, bypass the roll section and are pitched end for end before reaching the stacker. Letters face up, but with stamps trailing, are first rolled over and then pitched end for end to join the stream into the stacker tray. All letters just before stacking are thus oriented with stamps all in the same location, ready for the canceling and postmarking operation. As soon as a tray is filled, it drops away for transporting to the sorting area. An empty tray automatically takes its place. Development of fluidic control techniques for processing letter mail is continuing in areas where reduction in costs and improvement in performance, maintenance, and reliability may be achieved. In another postal contractor's laboratory, research into increasing the speed of present-day facer cancelers has evolved into this breadboard model of a high-speed transport system. It is being developed by R&D engineers to process double the current rate, up to 50,000 letters an hour. Operation will differ from current equipment to achieve this high speed. Here, near the feeding gate, one of two stamp detectors will be installed. All envelopes having stamps in the down position will be bypassed and sent to a second detector at the cancellation end of the machine. The remainder of the mail will be turned over so that the stamps will also be in the down position. A new type of turnover belt is seen here in slow motion. It is designed for gentle handling of mail as well as for long life. The letters with recognizable stamps are turned over to the down positions to merge and flow past a second stamp detector. At this point, the cancellation unit will be installed. All recognizable stamps will be canceled through use of a non-contact device now under development. 3 automatic traying devices will be installed at the end of the system in place of the 5 now in use in today's facer cancelers. A prototype model will be tested soon under actual working conditions. The present methods of shipping empty sacks from one area to another for reuse is either to stuff 19 empties into another one to create an unwieldy gross weight of about 70 pounds, or to roll and tie 5 empty sacks into a bundle. This is an R&D development to facilitate the handling and shipping of empty mail sacks. Inspected and flattened sacks are spotted at fixed positions along a horizontal conveyor belt. As the belt moves slowly at 6 feet per minute, loaders pile up sacks so that the stack arriving at a baler contains 120. Photocell control stops the conveyor when a stack arrives directly below the baler platen. As the baler compresses the stack to about half its height, metal strapping is inserted. Pressing the tension button feeds the strapping around the stack. This operation is now being automated. The formed and strapped bale then advances to the exit conveyor, while another unformed stack reaches the baler platen. The accumulator system now shunts the bale to the transfer and takeaway station. At this point, power trucks handle the bales for storage or shipment. Advantages of this system to post offices and large mailers include gaining of warehouse space and ease of inventory, easy mechanical handling, and more sacks per cube, with flattened sacks ready for immediate reuse at receiving areas. Designed to relieve mail handlers of the laborious task of emptying heavily loaded hampers of mail manually, this floor-level hamper dumper mechanizes the operation. The loaded hamper is positioned on the dumping mechanism. Raising the control lever latches the hamper securely, and automatic sequencing turns it upside down to unload the contents. Pushing the control lever downwards returns the hamper to floor level, where it is automatically unlatched. The controls are simple and designed for safety. Start button, stop button. A warning light turns red when power is on. Each operation is registered. Placing the selector switch in low position will dump a normal hamper to floor level. When turned to the high position, a hamper with extensions will be dumped to floor level. Or a standard hamper may be dumped into the hopper of a portable conveyor. The mechanism operates through a cycle of about 6 seconds for dumping and 4 seconds for returning the empty hamper to floor level. Another physical operation studied for mechanization is that of manual emptying of sacks of mail. This prototype sack shakeout system, developed by R&D and contract engineers, is in daily use on a workroom floor. A horizontal conveyor moves sacked mail to the shakeout table. Here, 2 mail handlers prepare the sacks for automatic shakeout. One removes the sack label and spreads the sack opening wide. The other clamps the bottom 2 corners of each sack into specially designed clamps. The clamps, fixed to a continuous chain-type conveyor, upends each sack at the edge of the table, and the parcels drop out. To ensure that each sack will be empty, an eccentric shaker arm shakes the sack. The parcels fall to a conveyor belt, which transports them to the sorting section. As the emptied sack passes through the system, the sack clamps are opened automatically, and the empty sack released. A prototype model of a high-rate belt sack sorter is under test and evaluation here in a large truck terminal. The sorter is 225 feet long. Sorting is by keyboard control to 40 separations, 20 at each side of the conveyor belt. As many as 6 trucks may be unloaded at dockside at the same time. Extendable conveyors moving into the trailer bodies as they are emptied assist during unloading. The sacks move upwards into the system. And arrive singly at one of the 6 keyboard positions. As the label on each sack is read, a 2-digit code is punched into the keyboard. The spacing of the sacks, placed on the belt moving at 420 feet per minute, permits simultaneous code keying at from 1 to 6 keyboards. When a sack reaches its coded separation, a pneumatically operated diverter is activated by the memory system. It opens and closes within 1 second, sweeping the sack to secondary sorting. This new type of diverter handles the mail as gently as possible. Since only a 2-digit code is required, it is easy to learn and key punch. The number of separations which can be made on this type of high-rate sack sorter is limited only by the space available. To mechanize loading and unloading of trailers and to reduce manual effort and time-consuming movement of portable conveyors, floor-level conveyors have been installed on one side of test vehicles. Power is brought from dock supply. Provision has been made through solenoid valves on the brake system to prevent truck movement unless power is disconnected. Note the use of hinged covers to prevent loss of cube space by loading directly on top of the conveyor. Use of this built-in conveyor for loading and unloading purposes is under study to determine efficiency and saving in manual labor. Also under test and evaluation is this vertical twin belt conveyor for transporting collection mail vertically to an upper floor. Collection mail is unloaded on a horizontal induction conveyor. Sacks, loose parcels, and miscellaneous mail move directly to the bottom of the twin belts for induction. Here, the mail is seized between the 42-inch twin belts, which carry it vertically upwards 33.5 feet to the second floor. Moving 220 feet per minute, the unit under test can handle in excess of 4,000 sacks an hour. At the top of the twin belts, the mail is discharged to a takeaway conveyor and carried to the second floor mezzanine for processing. The transport belt of the twin belts is stretched taut. The cover belt is loose, with pressure exerted on it by several sets of rubber wheels to hold the items being transported securely against the transport belt. Notice the action of the pressure rollers against the cover belt as a sack moves upwards. Sacks and parcels of all sizes, small flat pieces as well as trays filled with letter mail, may be transported vertically without damage. A prototype model with a longer vertical lift is being installed for test in another facility. This compact unit simulates actual operating conditions of the keyboard of a letter sorting machine. It may be used to test personnel for dexterity or to help them develop rhythm at the keyboard. The machine projects a number code or letter facsimile on the display screen, and the student responds by pressing keys corresponding to the number shown. When an error is made, miniature lamps illuminate the correct keys. By pressing keys which match the lighted lamps, the student learns correct fingering. The instructor's control panel provides means for method of projection of test or training code numbers, rate of speed of projection, and a method of recording errors. The printer provides a permanent record of student responses. The machine introduces the student to the principles of keying, trains him in forming code numbers, and helps him acquire the necessary speed to become a qualified sorting machine operator. You have seen a few of the research and development projects now active in the Bureau of Research and Engineering. Many others are in the contracting stage, in design, or under prototype construction. Each one will undergo its period of evaluation and testing. Those passing the stringent requirements will take their place in the system for mechanizing all operations of mail processing.